Hello, so today we will solve uh, the two problems. We'll try to solve these two problems from the priority queue part. So first problem is a design problem, which is design Twitter. So let's open this. Okay, so let's read out the problem. So design a simplified version of Twitter. Okay, users can post tweets, follow, unfollow another user, and able to see 10 most recent tweets in the user's news feed. Okay, basically we need to design Twitter where user can post tweets, follow, unfollow another user, and is able to see 10 most recent tweets. Okay, implement the Twitter class. Okay, we have to implement this Twitter class. Initializes your object. Okay, so this function initializes our object. Now the function post tweet, which takes user id and tweet id, composes a new tweet with id tweet id by the user id. Each call to this function will be made with a unique tweet id. Okay, so this basically means this user tweets this tweet. So this is a post tweet function. Now the next function is a list of integer get news feed. So retrieves the 10 most recent tweet IDs in the user's news feed. Each item in the news feed must be posted by users who the user followed or by the user themselves. So basically this function will return a list of integers, means a list of tweet IDs, most 10 recent tweets which are tweeted by either this user itself or the users which this user follows. Okay, so for example this user follows user 1 2 and 3 4, and they have tweeted 10 tweets from 1 to 10, so we will need to return that 1 to 10 tweets. Okay, so next function is void follow. So this takes a follower id and this take a followee id, means the user with the id follower id started following the user with the followee id. Okay, so this user will follow this user, means follower will follow followee. Okay, and in unfollow I think it will be reversed, that this follower will unfollow this followee. Okay, so we need to implement this class. Let's zoom in. Okay, so we need to implement these functions. So let me first define the function. So post tweet, what post tweet will do, so it will user id user with user id will tweet tweet id. So uh, this is to means we need to maintain a user's tweet, means we need a data structure where we can store a user's tweet. Okay, and we need the most recent tweets. Okay, so this will return 10 most recent tweets of user ID and users whom user ID follows, and it's following. 10 most recent tweet IDs in users newsfeed. Each item in the newsfeed must be posted by the users who the user followed or by user themselves. Okay, so this function will do follower ID will follow followee ID, and in this case it will unfollow the followee ID. So we need to implement these functions. So I think we can first implement this function. Suppose we can make a map of integer. I am just explaining this approach for this, if this could work. Map for integer means this means the user, and for its follower we can have a set where we can store its followers. So whenever a follower follows this, so what we can do, for this user, for followee ID we have one follower increased, so we can add two followee IDs follower this ID. Okay, so for example, if our function call is like follow 1 and 2, means if user 1 follows user 2, then what we can do is we can in the map put a user 2, and in its follower we can add 1, something like this. And if we get again a call like user 3 follows user 2, then in that case also now we have user 2 already in the map and its follower is 1. Now we can add 3 to its follower. So that's how we can use this map. And similarly, if we use unfollow function, we call unfollow like user 3 unfollows user 2, user 2 user 3 follows user 2, then in that case we can remove it from followers. So I think a map like this can work for these two, for implementing these two functions. Okay, for once let's initialize this map. Let's call this follower map, followers. Okay, so we have a followers map. Now let's look at the function post tweet. So what this function means is this function means this user will tweet this tweet, means tweet with this tweet ID. So for example, if we call post tweet function, post tweet function with user id 2 and tweet id 3. So this means suppose we have a map, we can store the user id and against which we can store its tweet id, that this user tweeted this post. And suppose this function again calls with the again the user tweets with the tweet id 2, then we what we can do is we can put in user 2's map that user 2 also tweeted 4 tweet. Okay, suppose we have also stored this part. Let's initialize a similar map tweets. Okay, now we have a function which we need to implement, get newsfeed. So what this function will do, this function will return test 10 most recent tweets of user id and its following. Okay, so what we can do here is we need its the tweets of this user itself and its followers, so we can find its follower from this map. Okay, suppose we have found the user and its followers, means its followers will be followers.get user id, means this will give us a set of its follower, and we also have this user id. Now we have these user ids and we can now call our tweet function, tweet map, and we can find tweets of all these users. But the main problem here is we need to find 10 most recent tweets. So how we can decide that these tweets are most recent tweets? So let's see how many tweets in total a user can tweet. So we can have 10 raised to the power 4 tweets, and a user cannot follow himself. All tweets have unique ID. Okay, so we need to find 10 most recent tweets. We need a data structure like which can store the user and its tweet, and tweets like uh, tweets like in sorted order, means in sorted order of time when it's tweeted. Tweets must be ordered from most recent to least recent. So this is the condition we need to follow. Okay, so let's figure out. We can use a priority queue, but what we can store in a priority queue, how we can store in a priority queue. Suppose against each user we use a priority queue and we give a rank to each tweet, and we can sort tweets based on that. Suppose we take a priority queue here of tweet ID, and suppose we take a pair here, a pair of like pair of a rank and tweet ID, and we store based on the rank. Now in order to find 10 tweets, we can iterate all priority queue of all the followers, and will pop out the user having the higher rank. So we need to do that operation for 10 tweets. We need 10 into followers time. So how many followers a user can have, let's see. So I think 500 is the max followers a user can have. Okay, we can do this also. Let's say this time instead of rank. Or we can do something better. I think we can first implement our follower and following part. Where's our following part? So follow and unfollow part. So for that we have this map. Let's initialize this map as followers will be new hash map. Okay, so we have initialized this map, and now what we will do, we will check if this follower is already present in our map. So what we can do is we can check compute if absent. So for follower id, so what this function will do, this will check whether the follower id exists in followers map or not. If it doesn't exist, what we will do, we will create its entry, and we will add a new hash, new set. So we will add a new set. Set of integers. So this will give us a set. So in that set we will add this followee id. So we have done nothing here, just we have added our this okay, we need followee id here. What we are doing in the followee id, we are putting the follower id, that for this user we have a new follower added. Okay, so we have added a new follower. Now in this case what we will do, we will unfollow. So first we will check if our follower id, means our followee id, is present or not present. If it's present, means if our followers map contains key, this key, if our map contains this key, then only we can remove from its follower. So this will make sure that this user is present in our followers map, and then we will remove this from its following. So what we will do, we will followers dot get so this gives us the set of the followers. So this is the this gives us the set, and from this set we will remove this follower id. We don't need to explicitly check that this follower id whether present in this set or not. This will remove if it's present. If it's not present, then it will take no action. So I think we have implemented follow and unfollow functions. Okay, so now we have to implement this function post tweet. So user tweets something. So for that we need a variable time, means the time at which this tweet is tweeted. So let's say we define a variable time. Initially the time is 0. We will initialize it in our constructor. So time will be 0 initially, and we will also initialize this map tweets. This will be a new hash map. And also we need to define this pair class. So let's define this pair class. This will be the inner class. Inner class means we are defining this class into the Twitter class itself. So public class pair. So what our pair will consist, time and tweet id. So in time and tweet id, and for the constructor we will pass time and tweet id, and we will define this dot. We will also define the empty constructor. This dot time, and this dot time will be equal to time. So this represents to this time, and this time is which is passed as the argument, and we will initialize tweet id, this dot tweet id as tweet id. So we have implemented our pair class. But we also need a constructor for our this pair class. So we will see how we can implement it. Okay, so the user posted this tweet. So in tweets we can check if our tweets dot contains key user id. This means we have this user already tweeted some tweets. So if the user already tweeted some tweets, so what we can do, you can simply tweets dot get user id. We have got a priority queue for this user, and we can add to that priority queue new pair with the time and tweet id. Okay, so we have added a tweet with time and tweet id. Otherwise, if this user's priority queue doesn't exist, we will create a new priority queue. So we will create a priority queue of pair new priority queue, and we will initialize it as new priority queue, and we will define a comparator for it. Means we will sort the element based on the time, means the elements with the tweets with the maximum time first, because that will be the our recent tweets. So we will define it like b dot time minus a dot time. So this will give us the max priority queue, and if we needed min priority queue, then in that case we will, what we have done that a dot time minus b dot time, so that will give us the min priority queue. So this is the max priority queue based on the time. So now we will put a new pair add a new pair to the priority queue, we have added a new pair to the priority queue, and now we will add this priority queue to our map, and at the end we will increment our time. So what we have done here is in the case user ID already exists in the tweets, we have added a new pair to that user ID, and otherwise we have created a new priority queue and sorted it based on the time, means max priority queue based on the time, and then we have added our new pair to this priority queue, which is time and tweet ID we have added, and then we have added that new priority queue we have just created to our map against this user ID, and then we have incremented time. So now we have implemented post tweet function also, that we have tweeted something. Now we will implement the function which will return 10 most recent tweets. Okay, so for 10 most recent tweets from user itself and its followers, so first we will find its followers. Let's initialize our answer first, integer most recent tweets as new array list, and if our map contains, okay, it's not necessary that our followers map contains tweets, because a user can tweet something and it is possible that it doesn't have any followers, so we cannot rely on followers. Okay, so we will find followers of the user, this user. So set of integer user followers, so that will be followers dot get user ID. So now this will store followers of this user. So now we have user itself and its followers. Okay, so at the last we will be returning most recent tweet, so let's just return now itself. So now we have this user's followers in user followers. Now we need to find 10 most recent tweets from this user and its followers also. So for now what we can do is we need to iterate the user's follower, and to avoid using this user separately, what we can do, we can add this user to its followers, and now we can iterate int current follower. Now from these followers we need only 10 most recent tweets. Okay, so we need to iterate all these followers, and all these followers this priority queue for users to check which is the most recent follower we have, most recent tweet we have. So let's define pair most recent as a new pair, and initialize this with -1 and -1. So initially we don't have any most recent pair. Now for this follower we will find its priority queue. So we will find a priority queue of pair. Let's call it user tweets, and that will be, we can find user tweet from this map. So map is our tweets map. So from tweets map we can call compute if absent our current followers tweet. Otherwise, if tweets are not present, please return as an empty priority queue. Okay, so what this function is doing, this is we are creating user tweets, and in tweets we are checking whether if this user posted some tweets. If this user posted some tweets, then we can simply get all the tweets in this priority queue. Otherwise we will get an empty priority queue of pair. Now we need to check if this peak of this priority queue is greater than this or not. And we need to do this thing 10 times, at most 10 times. So means we need to go through all the followers 10 times to find the 10 most recent tweets. Okay, so what we will do, we will now compare these users. Okay, so we will define most recent tweet here. So we will compare the most recent tweet users tweet. So if my user tweet dot size is greater than 0, then that means my priority queue is not empty. And I will check size is greater than 0 and my user tweets peak values. So peak I will be have most recent pair, peak values time. If it's greater than my most recent pairs time, then in that case I will replace my most recent pair. My most recent pair, I will define my most recent pair as user tweets dot peak value. So this is my new most recent tweet. So after iterating all users, I have found the most recent tweet. So I will check if my most recent tweet dot time is -1, then in that case all the priority queues are empty and I need to break my this loop. Okay, otherwise I will have a most recent tweet. So in that case what I can do is I can add that recent tweet to this answer array, means most recent tweet dot add most recent tweets tweet id. Okay, but suppose if I am doing second iteration, then second iteration also this tweet will be my this tweet will be my means most recent. So I need to remove this tweet and I need to store it somewhere. So let's say I initialize a list of pair removed tweets. So this will store removed tweets from the priority queue. Means now I need to remove most recent tweet from the priority queue it belongs. So what I can do is I can go to my tweets tweets map and get the okay. So the challenge is how should I find this tweet now. So one thing is I can store the reference of the priority queue from which I'm getting the most recent tweet. Let's store most recent queue here and store a pair and new priority queue. And so now my user tweet size is greater than 0, and here I can check. Most recent queue and its peak. And most recent queue dot size is either 0, or if it has some size, then I will compare its peak value, and in this case I can provide reference to this queue. So, and at the end I can check if my most recent queue size is 0. In that case I can break. Otherwise what I am doing, I am adding my most recent queues dot peak dot its tweet id to my most recent tweets. And from this queue remove tweets, so I can add my removed tweets to most recent queue dot poll. So this will store my most recent tweets, removed tweets. Now at last what I need to do is I need to put these removed tweets. So characteristics of a removed tweet is tweet id and its time. So I think I need to map the tweet id to user id, means what tweet a user made. Means I also need to map a tweet a user made, so that I can remove that, means I can re-add that remove tweet to that user's priority queue. Means I need to add remove tweet back again to user's priority queue. Okay, so what I can do is I can initialize a map of a integer which I can call user to tweet map, so that I can know which user tweeted which tweet. So means this user is tweeting this tweet, so what I can do is I can simply add this tweet id and this user id means this tweet is tweeted by this user, so this will be tweet to user mapping, tweet to user mapping. So I have stored mm, tweet to user mapping. So now I will iterate my this remove tweet list for a pair remove tweet and I will re-add these remove tweets. So how we can add these remove tweets? So we have a remove tweet, so we can find user which removed this tweet, means to which this remove tweet belongs. So what we can do is we can find like dot get so this will give us the, so this is the tweet id and this tweet id belongs to this user. We have stored it here. So now we have find the tweet id to user mapping and we have now user. So what we need to do is we need to put again this into this tweet users map, means c dot get users user dot add remove tweet. So we have added this remove tweet back to this user. So I think we are done with the implementation. So this was the difficult part, I think, implementing this remove tweet function. We have to verify if this works or not. So let's just reread our this function. So we have a user id, so we are making a list most recent tweet which we are returning at the end. We have a user followers dot get user id means we have now all the followers of this user. Okay, and we have removed tweets, and to user followers we have added user itself, because we all means most recent tweets can be from user itself. So now as we need 10 most recent tweets, so we will iterate 10 times and we have found the priority queue pair most recent queue. So now we have a most recent queue which will store the current queue which contains whose peak value is the most recent tweet. So now we iterate all the user followers. So iterating user followers, we will find tweets from that users. If from that current follower, if we don't find any tweet, in that case we will return a empty priority queue, and we will check if our user tweets means our priority queue is not empty and our most recent priority queue size is greater, it shouldn't be empty, and along with it if our most recent queue contains nothing, then we can put the user tweet in it. Otherwise, if it contains something, we can compare its peak value with the user tweet. So user tweet dot peak dot time, if it's greater than our most recent queues means most recent queues peak dot time. Then only this we will replace our most recent queue with our user tweets. After that we have iterated whole user follower list. Then we will check if our most recent queue size is 0, means uh, all the arrays we have iterated means don't contain any elements in them. So in that case we will break that we have found, means now no tweet is remaining. Otherwise we will add most to our most recent tweets, we will add most recent queues peak and its tweet id. And we will okay, what this thing, remove tweets. Okay, we will add this to remove tweets. So we will remove this most recent tweet from this priority queue. And at the end we will reinsert that removed tweets. So we will iterate these removed tweets and we can check from which user this tweet was tweeted, and in that user's priority queue we will add that removed tweet. Let's run our function. So we have some issues. Okay, we have error in line number 34, that is this error. Expected. What's the error we are getting? Let's ask on GPT. There is a typo. Specifically, it mixing correct syntax. Where's the typo? Okay, we need to add e here. Let's copy this and add this here. Let's run now. We are still getting error. Okay, we also need to add new keyword. Okay, we have some null pointer exception. Cannot invoke a put because this dot tweet to user is null. What is null? I didn't understand. Tweet to user. Okay, this map, we haven't initialized this map. We need to initialize this map. Tweet to user map. New hash map. Okay. That our followers means a particular user not necessarily have followers, so we need to add here get or default get, otherwise at default. New hash set of integer. Okay, so now our code is running, but it's not giving the correct answer. Let's see the test case. Okay, first we are calling post tweet function, means our one user will tweet post 5. Then we are calling get news feed, so our function is returning 5, means this is the most recent tweet. Then we are calling follow, means our one user now started following user 2. Then we are calling post tweet, so our second user tweeted 6. Now we are calling get news feed for user 1. Okay, so now we need to return, means one started to follow 2. So what we are doing, one started to follow 2. Okay, means one started to follow 2. These are 2's followers, but we need list to whom one is following. I think we need to reverse this, means now this means one started to follow 2. One started to follow 2. Okay, so instead of calling this should be following, not user followers. Okay, and in the case of unfollow, uh, if one follows 2 means this map contains this, we will remove this. Okay, let's run it now. Okay, so now it's working fine. Let's see our previous submissions. We had a runtime error. Which case was it? Okay, let's try to submit our code. Okay, we have got runtime error. Where we are getting this error? Why we are getting this error? Mm, class cast exception cannot be cast to class Java. What we are doing here is if our while posting a tweet, if the tweet already contains our user ID, then we are getting tweets priority queue. Okay, and in that priority queue we are adding new pair with time and tweet ID. Then what's the issue here? Okay, means we need to define comparator in our pair also, because this priority queue doesn't implement this. Let's try to copy this and try to run this. But we have implemented comparator here, so why then we are requiring to implement it again? Means what I am saying is we are implementing our comparator here. Where's my priority queue? Here. So why we need to define it for the pair again? Okay, we have got the submission, but I didn't understand that. Don't means let's ask GPT to. If you don't want to comparator in, you can define a custom comparator when initializing the priority queue. Let's see if we can avoid implementing it here. Is it possible? So we have some test cases. Okay, we can avoid it adding here. Make this implementation. Oops. And make code cleaner. Okay, we have defined a separate class user. User ID, against user ID we have defined a user. Now we have user dot post tweet. So new tweet time plus plus tweet ID. Followers tweets, post a new tweet, remove the oldest tweet to maintain a size of 10. Okay, private final. Okay, follow another user. If follow id is not equal to this dot user id, follow id, follow a user, unfollow a user, follow is dot remove, get the user's tweet. Instead of priority queue we are using a users rad queue. Okay, get followers. And in get news feed what we are doing, we are defining a user, and user dot get user id. If user equals to null then we can return empty list, otherwise we will initialize a max heap of tweets, user dot get tweets. We will add all the tweets of a user to the max heap. Add tweets from all the followees. We have added all the tweets from the followees, and then we have added 10 tweets, and then we have written newsfeed. So this is the pretty good implementation which is expected from us in interview, because here we have defined a separate user class. So without messing up the code, we are using a separate class. So I think we should be after doing LeetCode sheet, we will be doing only design problems, because these are asked in machine coding round. So design problems will help us. I think here also we have design problems, design pattern, so we can do these problems also. Okay, now we will solve find median from data stream. So this problem is unsolved by me, and this is in attempted part. So let's see what was my previous solution. So it is a TLE solution, it was a. So let's see what I have done here. So let's read out the question first. So the question says the median is the middle value in the ordered list integer. If the size of the list is even, there is no middle value, and the middle value is the mean of the two middle values. For example, here size is odd, then median is 3, which is the middle element, and in this example the median is the average of these two elements. So that's why our find median function returns a double data type. So we have three functions here. First is median finder, which initializes median finder object, and second one is void add num, means adding a number to the stream. Okay, means we have added a new number. And double find median returns the median of all elements so far, and answer is 10 raised to the power minus 5 of the actual answer will be accepted. Okay, there will be at least one element in the data structure before calling find median. Okay, at most 5 into 10 raised to the power 5 calls will be made to add number and find median. Okay, so basically this function will add numbers to our list, and while adding numbers, somewhere in between this function will be called to check the median, find median. So we need to return the median at that moment. So let's see my previous submission. So I think in previous submission what I have done is I have created a list, and whenever this add function is called, I have added that number to that list, and whenever find median function is called, I have sorted that list and checked what is size. If its size is even, then I have returned mid value of means average of two values. Otherwise, in the case of odd, I have just returned the middle value. So this functions gives TLE, because every time we are calling the short function. So this approach becomes n into n log n, which is n square log n. But I think the question is demanding our approach to be n log n. Suppose we have numbers like this 1 2. I have taken a number in sorted form. So here the median will be 6. Okay, and let's take the another example. This is the even case, odd case, and 6 5 6, take another 6. This is the even case. So let's say we divide this array into two parts, and also this array into two parts. So what we can see here is that in sorted form, this part will be my sorted part, and this part will be my sorted part. So this part is in increasing order, and this part is in also in increasing order. Okay. Means here we are taking greatest number 6, suppose, and here we are taking this minimum number in this array. Let's consider even example. So here we in this array the greatest number is 6. Okay, 6, and in this array the minimum number is 6. Means the let's say this is my A part, and this is my B part. So size of A plus B is even. So I need to take two elements. One from this part and one from this part. Means maximum from this part, from A array, and minimum from this part. So my median will be max of A part plus max of B part plus min of B part divided by 2.0. And here what I need to do is, so this is my A part and this is my B part. So here what I need to see is my size of A plus B is odd. So here my median will be the array having maximum, means the part having maximum element. So in this case A has the greater size is greater. So here I will return max of A array. And suppose my stream is increasing. So let's say now I need an element. Now I want to add an element 3. So I have to decide in which part I should add 3. So I will add 3 the part which is smaller. Okay, I will add I should add 3 in this part. Suppose I have added 3. Now in order to maintain the sizes, I need to remove this 6 and need to add it here. Okay, so I think we can use two priority queues. For this part we can use a max priority queue because we need maximum from this array, and for B part we need minimum priority queue, we need a min from this priority queue, and we have to manipulate our priority queue so that a number of element remain equal, or at most means the size difference is 0 or it's 1, means the size difference should not be greater than 1. If the size difference becomes greater than 1, then in that case we need to reshuffle our priority queues. So I will paste I'm pasting this logic here and will remove this part. So priority queue of integer, first one be min priority queue, second will be max priority queue. And min priority queue, as we know, the default priority queue in Java is min priority queue, so we not need to define comparator explicitly. And for the max priority queue we will define a comparator, like we will return b minus a, means the number appearing after should be greater than number appearing before. Okay, so we have defined our priority queues: minimum priority queue and maximum priority queue. Minimum will store these a elements and maximum will store these b elements. So now we need to add a number into our priority queue. So we will implement this later. First we will implement finding a median. So as we have discussed that first we will calculate a size of our priority queues, means if pq, if minimum dot size plus maximum dot size, if this size divided by 2 equals to 0, that means we need to this is this case we need to take peak of this max priority queue and peak of this min priority queue. So this is a max priority queue, this is the min priority queue. So what we need to do here is we need to return as we know that this function will not be called when these both are 0, means find median will be called let's see, here we have a condition, there will be at least one element in the data structure for called find median. If there is at least one element, then it should be present either in this and either in this. But here in order to get a 0, then both should contain one element each. So in that case we will return double of min dot peak plus max dot peak divided by 2.0. So this will give us a double value. Now one case can arise. Else condition will mean that our this size, this sum is odd. So in that case we will return peak of the array whose size is greater, for example this case. So here the median will be 5, so this array has a size greater. So what we can do here is if min dot size is greater than max dot size, in that case we will return min dot peak, otherwise we will return max dot peak. So this is the implementation of find median function. Okay, so now the our core logic comes, which we need to implement here is while adding a number. So we need to manipulate our both priority queues, that how we will gonna manage smaller and greater numbers into these. So I think this looks perfect. So let's implement add number. So we are taking this example. Okay. So we need to add a number. Suppose we are at this situation. Let's say we have a 4 here. So we need to add a 3. So now beforehand we know that 3 will be added here, and this 5 then will need to shift at this position. So how we will decide that where this 3 will be added? So we will compare this 3 with these peak values. So if my 3 is smaller than this value and also smaller than this value, then we know it needs to add in this part. Okay. Let's see if my number is smaller than, let's say smaller than equal to, I am also considering this case. If we are adding 6, then I will be adding 6 to here, means if it's equal also. So if num is smaller than min dot peak and also num is smaller than equal to max dot peak, in that case what I will do, I will add my number to my max, means this is the max array, max priority queue. So I will add max dot add add number. Okay, if I have a case that my number is, suppose instead of 3 I need to add a 12 here, so my 12 will be greater than both these values. So in that case I will copy this part. If my num is greater than both these values, so in that case I need to add my nums to my min value. So now one case is left. So that case is if the number is in between these values. Suppose the number is 6, so I can add 6 to this side and also to this side. Suppose I have this array and the size is odd now, so I can add 6 to this side and also to this side. Or I can say I have this case where this size is 1. Okay, so in that case I can add the number wherever I want. So let's say in the else condition we add this number to this array. Means we are adding in that case when the number is in between these two values, so we will add to the b part. Now let's say if my max dot size becomes greater than my min dot size, in that case I will add that max element to min. Else if my max dot size becomes smaller than min dot size, then I can do reverse. So this will also work when the size is 1, means the difference is 1, which is okay. So in that case also we will shift that element to another priority queue, so that will not impact our priority queues. So this will work for size 1 also. In the equal case we are doing nothing because our priority queues has equal element. Okay, so now we need to handle conditions when one of the array is empty. We are accessing peak element without checking whether our array has some element or not. So if our both arrays min dot size is equals to 0 and our max dot size equals to 0, both arrays have size 0, then in that case suppose we add this to our min array, the number, and we can return from here itself. Otherwise if our one of the array is empty, if our min dot size equal to 0, then we can add that element to max array. Otherwise we can add to min array. Otherwise we can add that to max dot. Means we will add after this point. So this condition will handle when both priority queues are empty, then we will add to minimum priority queue, and after that we will check if our, so this condition will only work when both are let's say both are both are empty. So now let's say one array is empty, so we will skip this condition and we can check. So whichever array whichever priority queue is empty, we will add to that priority queue, and after that these conditions will work okay, because we are not we are only, after this condition the arrays will have at least, both priority queues will have at least one element, so that will work. Okay, so I think let's try running it if this works. Okay, so we need to add this condition here. Okay, we have got wrong answer. So find median, we called function add number, we have added 1. Then we have again called a number, add number, add 2. So let's print our priority queues. This is min priority queue, this is max priority queue. So okay, so we are returning here. We can also add these print statements here also. So let's see what we are getting. So add number, so initially both are empty, so we will add to min priority queue. So min priority queue will contain 1 only and max will be 0. Then what we will do, okay, what we are doing here, okay, then we are what we are doing, we are adding 2. So in order to add 2, we will check if our min array size is 0. No, it's not 0 as it contains 1. So we will go into else condition. We will add 2 to our max array. So now our max array contains 2. Okay, then this condition will also run. So we need to avoid this, means either this will run or either this will run. So what we can do is here is, if max dot size is 0 or this condition, then we can remove dependency on this condition, I think. Let's run. Okay, so now we are getting correct output. So I have merged that condition. When max size is 0, we will add to max into this condition. In this, functions will not also be impacted. Suppose max size is not 0 but min size is 0. So what I can do here is, we also need to add a check that min dot size is not equal to 0. Then in that case it will not get a null point exception. Okay, so we only have one test case, so I think we can also use this test case which got TLE. We need to comment out these print statements. Okay, this test case is not working. This for this particular part, I think. Here it not giving correct answer. I think there's some issue with our implementation. I think if we get let's say, can we edit this test case? This is the test case. So this is a very huge test case. Our compiler is getting hanged. So how we can find the issue? Let's see. Max priority queue, min priority queue. If size is 0, then in that case we are adding that to min priority queue. So let's have a data stream like 2 1 3 5 4. Let's say we have this array 2 1 3 4 5. So first we will add 2 to our min array. So let's say we have min priority queue and max priority queue. So we'll add 2 here. We have added 2, then we will return. then we need to add 1. So we will see. So our max array size is 0, so we will add 1 into max array. We have added to the max array. So let's debug. So I have pasted these operations, and also we need 1 2 3 4 5 6 7 these. Okay, 1 2 3 4 5 6 7 before now we need. And required output is okay. So first is we have initialized median finder, then we have added a number. So initially number will be added to, or I can just use this input. So how we need to add this input, this input, this input, and this input. Let's go to test cases. We will have a test case of our own. And an array. Let's run. Oh, this will give us error. Okay. So this we have found a test case which is giving wrong output. So we will print our these min max arrays for these. Okay, so initially our min will contain this part, max will contain this part. Okay, so I think we need to explicitly handle this our condition of size. Suppose if our max dot size is 0, then we will compare, then we are sure that a min will contain at least one element. So if min dot peak Okay, we have initially one. Suppose our min contains 1. Now size of max is 0 and our number is 2. So this number we need to add to the min, and that min's number we need to add to the max. So we will check if our min dot peak is greater than number in that case we will add that element to max, and we will add number to the minimum, else we will add it to the max itself. Min dot peak is smaller than num. Then we will return, and same condition we will write here. If max dot size is 0, in that case we will check if our min dot size we will check if our min size is 0. Then in that case our max will contain something. Suppose our max contains 2. If it's greater than num, then we will reorder it and return. So I think this case will be handled now. Let's see. We have written too much conditions. We should once our logic works, we will shorten these conditions. Okay, let's see if our this case is working now, the TLE part. Okay, I think we are printing something. Okay, let's try to submit this approach. Okay, we have got a submission, but the issue is we need to shorten this logic, as this logic is pretty means looking pretty complex, and we are handling it explicitly. So let's see if there is another way. Okay. So min dot peak is smaller than max dot add dot else we are just changing numbers. Means first two numbers we need to handle carefully only. Okay, so I think we can add two elements if one array is empty. So what we can do here is if our min size is 0, that means our max size is not 0, so we will add that element to the max array. Or the other condition is if our min size is not equal to 0, max dot size is not equal to 0 and n. I think this should also work. Okay, let's submit this. Okay, we have get rid of this complex logic. So what we are doing, we are adding two elements, so this will handle our two elements condition. Okay, so this is the perfect approach I think for this question. Okay, so I think we are done with the heap part. So tomorrow we will start with the backtracking. So now I think these are the advanced topics to which we are moving now. So these are the common problems. We will try to submit this as much as faster we can. So try is a bit advanced topic. Graphs are also advanced topics, and then we have advanced graphs also. These are good questions, I think. And then we have a 1D dynamic programming, 2D dynamic programming, greedy problems also. Then we have intervals. Okay, so I think we are almost halfway done. We will be halfway done after we will solve backtracking problem. We have left some easy problems here also. Three problems, easy problems are here. So these are very easy. This doesn't make sense doing these. This is also easy problem. Okay, that is it for today, I think.